completely fine, although for some reason I can't hear anyone speaking, which is a bit odd. So let me just share my window. Okay, let's go to Google News. So we're going to walk through essentially the problem of decentralized contact tracing. So there are basically DP3T. There we go. So the problem of decentralized contact tracing is effectively the issue of how to discover who, if you've been infected with corona, who you've talked to, who you've met, and to alert them that they may also have corona without having to reveal your identity to them, so they don't know it's necessarily me, and they don't have to reveal to anyone else, including a central government or government authority, that they also have corona. So this sounds impossible, but we can do it with Bluetooth. So how Bluetooth? So can you guys maybe, is it possible you chat to me in the text so I know if this is working? Can you guys see the DP3T GitHub there?
Am I chatting in the right
GitHub? Okay, cool. So now I'm just going to walk through. I'm going to give a really brief description of this design, and then I'm going to talk a little bit about the Mixnet designs, and then I'm going to talk about the centralized design being put forward by the French and German government. So if people are interested, if you go to NIM's Twitter, we just released a blog post that kind of explains, and much more or less what I said, the problem of decentralized contact tracing. But let's look at the actual technical solution. So the first and primary technical solution is called DP3T, which stands for Decentralized Privacy Preserving Proximity Tracing. And there's a very nice overview on this link here. And this basically lets you, how it works is I'm going to go straight to the cryptography because I'm assuming everyone here is pretty technically and politically savvy. So this is the main proposal, but if you want to actually take a look at the technical parts, you want to go all the way up. You want to say, well, how does this work? So you see there's lots of code. You have Android, SDKs, iOS, but what you want to read first is you want to go to the cryptographic part of the protocol, which is in what's called DP3T white paper. And you can see it's got most of Europe's leading cryptographers behind it, including NIM advisors, Carmela Troncoso and Bart Purnell. And various countries, Estonia, Austria, and Switzerland, have already said they will adopt this technology. So it's good to understand this technology. So we're going to go, so there's these cartoons. These cartoons try to explain the real basics. And the basics are that rather than identify yourself directly, you identify yourself with what's called an ephemeral identifier. This ephemeral identifier is essentially a random string that changes every so often, like 10 minutes. And as you're walking around, you broadcast this random string. So if I meet you at a, let's say, not a cafe because those are illegal now, but let's say we're out jogging or doing our exercise and I jog with you, or my ephemeral ID on my Bluetooth phone would be shared and with your Bluetooth phone and vice versa. You see this ephemeral ID is being continually broadcast using Bluetooth and is being stored. This is what's decentralized. It's not being stored in a central server. It's being stored locally on the phone itself. Then what happens, and how are these ephemeral identifiers created? So this is the most important part. Look at what's called look at the top of this page. So again, go direct to page 10, ignore all of the blah, blah. You see what there actually is each day, your smartphone creates a new secret key. That's the SK. And it takes a hash of the SK and then go down a little bit and you say smartphones generate a list of new ephemeral identifiers, quite a lot, because they need to broadcast a new one every 10 minutes throughout the whole day. That's 24 hours, one a minute, 60 minutes. And then what they do is they basically take the secret key, they run it through what's called a pseudo-random function, which is just a stream cipher, HMAC SHA-256, and they add a little salt there called broadcast key, and then you basically take the result of that hash, which is a quite big hash of this key. You push it through the stream cipher, and the stream cipher basically produces these ephemeral identifiers, and you just basically, cut that giant identifier up into 16-byte chunks, and that gives you your ephemeral ID. So the important thing about this is that crypto is actually really simple. You make a new key every day. You use basically a quite normal stream cipher to take that key, to transform it into like a really long random number, and then you cut that long random number into 10-minute, 16-byte intervals, and you release one of those every 10 minutes. So how that works is that means that anyone who has my key, that SK there, can then generate the identifiers. Because if you look at this process with the broadcast key and the stream cipher, it's a deterministic process. So that means that it's replicable. There's no real, there's no randomness which cannot be redetermined locally, right? So that's great. What this means is that why is this great? It means that I can store my key and all these identifiers on my phone. That there's no server, there's no central server, which could be surveilling me, which knows about these ephemeral IDs. I can generate these ephemeral IDs, and that can basically pretend to be me. Now, there's some attacks here. You can imagine I intercept some ephemeral identifiers and I rebroadcast them, but they're a little bit strange because their ephemeral identifiers can change every 10 minutes. So you'd have a 10-minute window. You can maybe pretend to be someone else. But you couldn't, after that window, because you didn't have their secret key, you couldn't pretend to be them anymore. Then, if you want to basically, the question is, so everyone has these secret identifiers. They all have these secret keys. They're broadcasting these secret identifiers, these ephemeral identifiers, which are created by their secret keys. And then the real question is, how is it that I can then determine if I have corona, that I can tell my contacts without a central server knowing? Okay, so that's the real important question. This is the other big trick inside of DP3T. So how it works, let's see. This is how it works. This is it. So I'm a patient. I have my phone app on. I get diagnosed with corona. So you see in step 2, it uploads SK, which is my secret key for the day, to a server. And all the server does is the server, only doctors can upload the secret key. So I can, as an individual, just sort of like pretend they have corona and spam people by saying, oh, I got corona, guys, uploading my key. No. It has to be authorized by a doctor. That doctor then uploads with your consent, or you do it with your doctor's consent, your key to the backend server. That's the yellow box. And then that backend server then broadcasts that secret key. Anyone in the entire world can read that secret key. And so everyone else who has this app, every hour or so, they basically poll the server and say, has anyone new been infected? And if someone's been infected, they download that key, which is pretty amazing. And then from that key, so you see that step 3, you're broadcasting the secret key to all the other phones. And then step 4, you take that key, you compute, because that key lets you recompute all those ephemeral identifiers, because you just run that stream cipher over that key, which I think is just AES GSM. And then you get these ephemeral identifiers from all the infected person, and then you check. So you've generated the step 4, you've done the first step, you generate all the ephemeral IDs of the infected person, and this goes on not just for, 1 day, but for the last 2 weeks. So in case you've met someone, because you're infectious for about 2 weeks, you check to see if the ephemeral identifier is in your database of the identifiers that you've seen while walking around, while jogging, while hanging at your house, you going shopping. You've seen a bunch of these ephemeral identifiers, and that Bluetooth, remember, is recording those ephemeral identifiers, but not on a server, in a local database on your device. And if those two identifiers match, then you say, oh dear, yes, I might have corona, so I'm going to go to the doctor to get checked. And that's how, in a nutshell, decentralized contact tracing works. The DP3T design. There's some other tricks which I'll mention very quickly. So someone might say, well, it's kind of bad if I download this key because then maybe I can kind of guess who's infected. So there's a more advanced trick, which I wouldn't recommend anyone hack on because it involves more advanced crypto, but involves something called what's called a Kuku filter. And this Kuku filter, it's the same algorithm, but rather than uploading a key, you essentially upload a kind of like Kuku filter is kind of like a Bloom filter. It basically takes a bunch of data and like you can check to see if something's in that data or not without knowing what the data is or knowing all the other things in that data, the set of all things in that data. And for Bluetooth tracing, the Kuku filter is just a set of ephemeral IDs of people that have been infected, and then you just check so that the key is never revealed. And there's some nice privacy properties of that, which are a little bit nicer than uploading and downloading the key. But then you have to do this kind of complex Kuku filter, which is not part of like standard crypto libraries. So you can imagine, let's say I'm an Ethereum hacker and I want to make like an Ethereum decentralized dApp version of DP3T. And, what you would do is you would say my local device would have a key, which could, for example, be, my private key for my Ethereum address. I take that key. If you wanted to make just like the Ethereum version of this, I wouldn't really. It's an interesting exercise. I don't know if I'd recommend people use it, but it would help you understand the algorithm. You take that key, you run it through the stream cipher, you make these ephemeral IDs locally, and then you could basically imagine, although I think it's maybe a little bit dangerous, but it'd be a kind of a fun hacking program. You could upload that key, your key, if you've been infected, to like the Ethereum blockchain. People could check the blockchain and say, oh, this is a secret key of someone who's been infected, and they can recalculate locally those ephemeral identifiers. So if your connection to Ethereum was pretty anonymous and that key didn't have any funds in it, but was just like a key you generated with Solidity or whatnot, that'd be a nice way you could adapt this system to Ethereum. So then rather than talking to the box in yellow, the centralized backend, you could be talking to a blockchain. But there's some privacy problems there, which are realistic to have, because those privacy problems, if you put the keys of all the infected people on a blockchain forever, maybe that could be somehow used against someone in the future if there's some data leakage from their phone or something. So why don't we take a little break for a second, and then okay, good, thank you. Okay. Those are the two correct links, and then we're going to do another design, which we don't like, which is a centralized design. And this is the design which is currently being discussed by the French and German governments. And then finally, we're going to end with the Mixnet design. But we're going to go through, this is the PPD. This is actually a good overview. This post here is a good overview of all of the different designs. If you speak French, there's a lot of stuff in French here as well. But the most important thing to think about this design is that, all of these academics from all over Europe designed this wonderful decentralized design. And then what happened is the German and French government basically said, hey guys, we want a centralized design. We want to have a database of everyone who's been infected and everyone they've talked to, what you can't do with DP3T because all of the contacts are stored in a decentralized way on people's phones. There's no central way to know who's talked to who, or at least not easily, without doing like really crazy monitoring. So the German government put forward this proposal. Let's see if I can still find it, which is called the NTK proposal. Maybe internet seems relatively slow. Has it been taken off? Maybe it's been taken. Let's see. Just wait a second. Okay, it's not opening. But there's another. Anyways, the German government has a very secretive system, which isn't that interesting to look at. And the French government is putting forward their own centralized system called Robert, or the Robust and Price-Preserving Proximity Tracing Protocol on GitHub. And so this is the French proposal. That being said, and it's the same thing. You can file GitHub. You can read it. You can file GitHub questions. I monitor these GitHubs pretty closely, and you can read about the French design. So this is the French design. Can everyone see that French design? Okay, cool. Exile surfer seeing them, so you can see the French design. So the French design seems to be similar to, you have these contagious people and you want to find out who they are, and it's not as easy to read as the DP3 design, but you can say there's, and it looks similar. You're generating these Bluetooth identifiers. You can sort of see they're going through a key here. Fine. This all looks vaguely similar, except to when you get to this part. Because what's actually happening, and this is the key, is the server basically gives you your identifiers. You don't have your identifiers generated locally. Sorry, it's not a very well-written proposal. I'm trying to find the right part of it. Give me one sec. You don't have your identifiers generated locally. You register to the French government server using TLS, as they show here, and then the French government server basically sends you, they have a permanent identifier for you. See that IDA? And then they basically give you a list of ephemeral identifiers, which they generate on your behalf. So this design does the same thing as the DP3T design, but it's centralized because rather than building the ephemeral identifiers locally from a key that only you have and that only you publish when you're infected, the server basically generates all of the key material and the identifiers for you. So obviously they can use this to track you, and this is, we think, pretty dangerous. And it seems like the French and German governments are pretty into making this happen. Now, what's been interesting is TechCrunch. Let's see. There's been Apple, I think, has a proposal. Apple.com. Just wait a second. So Apple and Google put out their own proposal. And this proposal you can read about on this website, and it's the joint Apple-Google proposal. Sorry, I just downloaded a giant specification. Oh, oops, sorry, I almost forgot. And if you want to see it, it's a little bit disappointing because this is all they have. This is the German government proposal, which is all a bunch of nice blah, blah. But if you look at it very closely, that's it. There's no details. There's no cryptography. There's something about Bluetooth and data collection, and there's some sort of server which controls everything. So you don't even really want it. We can't even really judge the German government proposal because there's not enough details, but it looks really dubious. The Apple and Google proposal, everyone assumed was actually really dubious. But weirdly enough, one of the big problems with Bluetooth is that when you run Bluetooth in the background, it basically burns out your battery unless you have some extra support and all this. You have to generate these keys, you have to broadcast these identifiers. And so Google and Apple basically took a version of DP3T, which you can read here. Sorry, let me see if I can open that PDF. I can't open the PDF, but if you go to that cryptography specification, you can basically look at the Google and Apple proposal and determine if it's safe or not. And effectively it is, they've released their APIs to be compatible with DP3T, and their APIs are not compatible with the centralized German and French government proposals. And this is leading a big mess where the French German government are telling Apple and Google, which is really backwards, saying, well, can we have better control over Bluetooth so we can violate user privacy? So it's sort of weird. Google and Apple are sticking up for privacy, and I don't think they're doing it because they're good people. I think they're doing it because they're being very cautious. And also, to be honest, you saw different papers. It's very easy for Google and Apple to read the DP3T paper uses very simple crypto and figure out how that works. And that proposal from the French government looks like a bit of a mess and is very hard to read. On the other hand, let's talk about the Mixnet proposal. This is a sort of fun one. Now, this one, if you go over here, so one of these problems with these proposals is they all involve Bluetooth, but they still involve the server publishing this key. And maybe if you want to use Ethereum, you publish on a blockchain, and maybe you don't want to publish. Is there a way you could do privacy preserving contact tracing without publishing any keys? And I'll just give a very quick overview of how a Mixnet is used to do this. I can use a Mixnet to basically sort of say, these identifiers that you're broadcasting, they're not identifiers that are generated from a key. These identifiers are a bunch of anonymous mailboxes. And these mailboxes are anonymous because they are generated new with each identifier. And the pattern of talking to those mailboxes, putting information there, and retrieving that information is all anonymized via using a Mixnet, which is a sort of Tor-like infrastructure with a bit more protection, cover traffic, and et cetera, et cetera. And it's very good for like email kind of applications. And we at NIM Technologies, we have a Mixnet, so we're very excited by this proposal. And what's really nice about this proposal, which I recommend people read if they're interested, is that rather than having a central server that doesn't know anything about your key, you basically, all you have is a contact list, and that contact list, you don't have to keep your local contacts on your phone. You just broadcast these identifiers, which essentially are pseudonyms for mailboxes. People walk around, broadcast these pseudonyms for mailboxes, and when you get infected, you can send essentially an email message or message to each of these identifiers, and they roll back to the mailbox, and then that person then gets essentially a message saying that they've been infected. And all of these mailboxes are completely anonymized due to the Mixnet, because these mailboxes essentially are run on the Mixnet equivalents, which are called NIM servers, essentially the Mixnet equivalent of what's called Tor hidden sources like WikiLeaks or SecureDrop. Essentially, they're not a known IP address, they're not a known server. It's just a key material, which it's basically a public key, and you can send messages that public key and retrieve messages when wanted. However, the problem with this system is that it's pretty easy on a mobile phone to take a key and generate 20,000 16-byte strings. You have to do the same thing with a Mixnet, but you have to generate 20,000 mailboxes, anonymous mailboxes. And so this actually ends up being pretty computationally expensive. It's nice because it's not on the user's device, but it's kind of a lot of overhead and requires a lot of people running NIM mix nodes or servers. And we have a Mixnet. Let's see if he's released the code. So this guy has some code. It's a bit mysterious. Doesn't look like he's working on it too much, but it'd be fun code to pick up. You can see that he's been doing a little bit of coding, looking at Mixnets. And if you're also interested in maybe rebuilding the system in Rust, which we're kind of interested in doing, you can go to our GitHub, and we have essentially all of the Mixnode code in Rust, including compiling down to WASM. And so we could, in theory, easily support basically building this kind of system. And we have a lot of docs about how to install a Mixnode. We have, if you don't really want to go, you can easily play around with it. And if you want to talk to us, we have a very active Keybase channel where is it? There it is. Where you can just join this public Keybase channel, and we're more than willing to kind of mentor and help people run these mix nodes. We have a Mixnet that's already working, so you don't need to build your own new one. Let's see how it's doing. This is all of our mix nodes. You can see we have, I don't know, maybe 20 or 30 mix nodes already running. So we probably can't do Mixnet enabled privacy for like an entire country, but we could definitely do it for thousands of people. If you feel like for a hacking project that this may be too hard, this Mixnet based stuff. There's a lot of easy stuff to do that you could use a Mixnet or Tor for. For example, if you go to DP3T, you can see in the step 2, your phone is talking to a server. You might want to hide that connection by using Tor to talk to the server to hide your IP address or to reveal these keys, or go over a Mixnet. So there's very simple ways to add a Mixnet or Tor to the server. And, if you want to do some fun Ethereum hacking, you could try to replace that server, that centralized server, with a blockchain. So those are kind of the hacking projects I thought of. I'm really sorry my audio is not working. I'm going to debug it and come back in, but I'll be around all day today and in the chat channel. So if anyone has any questions, you can just chat with me anytime, and I'll try to get the audio working properly. Actually, great question, Fanny. No, I haven't. Yes and no. We have not talked to Radical Exchange. So if you want to introduce us, that would be great. We have, NIM advisors run DP3T. So we're in close, I would say, daily contact with them, which is great. And via them, we've been in touch with the Swiss government. We also put applications to the Irish and Dutch governments to create more privacy-preserving decentralized contact tracing, and we were rejected by the Dutch government and are kind of got no response from the Irish government despite some initial interest. It looks like what's going, in the United States. Okay, so I live in Europe. I've lived in Europe for a very long time. Dual U.S. European citizen. So I'm not super familiar with what's going on in the U.S., but I can give you. I know some things. In the U.S. there is a MIT effort called SafeTrace, or what was it called? SafePaths. I think that's it. And SafePaths is attempts to do corona tracing, but we think, to be honest, PrivateKit, it's very dangerous, the U.S. approach, because the U.S. approach is based on GPS and trying to anonymize GPS data. And GPS data, which is both inaccurate. I mean, Bluetooth isn't so great, but GPS data is super inaccurate. And it's super hard to anonymize, and basically involves government U.S. telco cooperation. So we don't really think this MIT design. I mean, this MIT design is better than like the Israeli thing, which is we just surveil everyone's phones, or what they do in South Korea. But it's not a great design, and we kind of hope the U.S. adopts a DP3T design. There's also, that would be great. I would love to be introduced to those folks. And the other design, which people have been talking about, no, we haven't looked at Taiwan, actually. That's a good point. We should look at Taiwan. We did look at the Singapore app, which is the famous one. And the Singapore app is vaguely close to DP3T, but has a kind of centralized server backend. I'm not sure what's going on in Taiwan, actually. But I do think in terms of privacy, the European approaches are generally better unless the French or German government gets their way. So it's actually a really big deal. If you did make an app or you had some good proposal, the French government is voting on Tuesday. So expect a lot of news. And it looks like Apple and Google and the French-German government are in some sort of negotiations. That being said, lots of European governments seem to be pushing for decentralization and privacy, particularly Austria, Switzerland, and Estonia, which is a pretty weird combination. All will release DP3T decentralized approaches by, I don't know, I think May 11th or something, this next month. And they've already, they've already pushed it. So I'm happy to talk to Audrey. I've heard of her. She's very famous. I hope she has time enough to check out an email or look at a tech document. But I would make sure the Austrian government doesn't do anything dodgy. I mean, governments often do dodgy things, but everything's moving so quickly in this space. It's a bit of a mess. And we at NIM are happy. We are building the components to make stuff, to make more privacy versions of this. We don't think, maybe. I mean, I was kind of surprised Austria really pushed the privacy version, so something's going right. And so what we hope to do at NIM, and maybe hackers could also do, is we can imagine more as we start deploying, these designs will iterate. They will get, we'll learn a lot from how they work and how they don't work. Maybe no one will use them, or maybe the Bluetooth is too coarse grained to really make sense. But the great news is, we are seeing a lot of governments be responsive to privacy and a lot of concern from citizens. So that's great. We're really impressed. If you had asked me 2 weeks ago, would Corona definitely lead to a surveillance state a la Israel with giving Shin Bet control of everyone's Corona data? I would say, yeah, sure. And I'm happy to see Europe do some pushback. Oh, great. Okay, I've never met them. Those sound really well. They're doing the right thing. So, I'll happy to take any questions and chat. But I also understand people have limited time. You want to get hacking, and I also need to fix my audio somehow so I can hear you guys. Happy to. I'll be around, and if people stay up all night hacking, I will also be up all night to give any advice on Corona or Mixnets or whatever people want to do. Okay, thanks so much, Fanny. I'm sorry. I'm glad at least you guys can hear me. I'm sorry I can't hear you, but at least we can chat together over text, and I will get the audio working very shortly. And I'll just be in the chat channel all day.
Great.
Cool. So, thanks so much, everyone.
Thank you. Michael, I think in terms of the chat, I think he means the Interspace one, right? Just to make sure we can find him easily. Not the ETHTurin one, but I don't know what's best for people to reach out to him.
We should post the link in the Interspace.chat to the ETHTurin chat for the hackers. So
and I think I was trying to chat in during the talk, when just open chat for this room, but it goes to the conference room channel, not to the mentoring, but it's.
Yeah, okay, no big deal. Anyway, in the mentoring channel now, just at Harry with the invite to the ETHTurin hack channel so that he's in the right one.
Okay.
Yep.
Okay, perfect. Will do. Any comment on the?
Yeah. No, I mean, I drew Harry in because, I know what he's doing. I've been following. I'm in their Keybase group and been following their work and stuff. So I'm good. I don't have any questions.
Yeah, no, I mean, this is quite a fascinating subject, and where the faster.
NIM's on the front edge of developing the Mixnet side of this stuff, and Nadim, is I don't know if you know who Nadim is, but he's an ex-student of Harry's earlier. He's one of the top encryption guys and cryptographers. He's a really smart kid. So yeah, they're moving fast on this stuff. Yeah. Good morning.
No, this is great. Louis, you say hi. You say goodbye. This is the end of the mentoring. Goodbye.
Goodbye, mentoring.
He just woke up. It's 8:40. All right, we'll see you on the other side, maybe in the conference room. I need to pee, so I'll go pee. All right. Thank you, Michael. Thank you, everybody. Thank you, Kay.